Welcome. Now question number 92. This is same as last time question. See, last time two questions we solved where this was rough, this was also rough. Some friction here, some friction here, if you remember, or if you have solved it. Okay, now, next question what I will do is I will give smooth wall. See, it is given in the question, this is a smooth wall. Smooth wall given in the question. Okay, now start. A ladder of length L. See, actually the length is not required. You know last time in such questions, if there is no other force acting, if only weight of ladder is there, then the stability will not depend upon length and weight. It depends upon only angle and friction coefficient. That's all. Anyway, you solve. So, a ladder of length L. See, I try to solve maximum questions in terms of bookwork type, WL, so that concept is more clear. When numerical is there, I try to give exercise for you. A ladder of length L is leaning against a smooth vertical wall, leaning against a smooth vertical wall. The center of gravity of the ladder is at distance of 3/8 of L along the ladder from the bottom. Okay, see, be careful. This is important statement. This I already told earlier. See, those who studied thoroughly, they know all these things. Coefficient of friction between the ladder and the floor, so this is floor, is 0.25. Here 0.25. That is not smooth. See, leaning against a smooth vertical wall. Okay, then find the angle of inclination of ladder when it is about to slip. Make a note. When the angle of inclination of the ladder, we have to find angle of inclination of the ladder when it is about to slip. Only due to weight. That's all, no other force. That angle, last time question was given what? Find minimum angle and maximum angle. See, or remember, I told you this angle with horizontal, if it is lesser, ladder is unstable. So, you require one particular angle. So, if you refer to this angle, what answer you are getting? See, 56.310 degrees, what you are going to get later, that is the minimum angle as per last question. Or this angle, if it is 56.310, that will be 33.69 degrees, correct? 33 point, okay, calculate 33.69 most probably. Why unnecessary struggle? Later you require it. So you are made 90 minus 56.31 is yes 33.69. Okay, I note down. I require later. So if this is 56.31 degrees, that angle will come how much? 33.69 degrees. See that angle. If the angle is more, see, with the vertical, see, the angle is what? How much? It is 56.39. If the angle is more, unstable, why? Slipping chance. If angle is lesser, ladder is stable. So, what answer you are getting with horizontal here, 56.31, as per the previous question, is minimum angle for stability. And what angle you are getting here? From this, in this question, suppose you solve this as theta, it will be 33.69 is the maximum angle for stability. This all I told earlier. So, but this time, see last time one question I asked you minimum angle with horizontal, other question I asked maximum angle with vertical. Both are same meaning. Minimum with horizontal means maximum with vertical. But this time, directly they told, they are not bothered minimum maximum. They told find the angle of inclination of the ladder when it is about to slip. Okay. Now start. Note. One statement you have to write first. See. When you start solving, see, I'll put here now. Solution. Okay, I'll write solution here. Where to write solution? Here. Okay. I start solution. You start solving, tell you, see. You make a note. In the question, it is not told whether you have to find the angle of inclination of ladder with horizontal or vertical. Nothing told. So, when nothing told, you consider with horizontal. So, right here, let theta be angle of inclination of ladder with horizontal, then when it is about to slip, when the ladder is, don't see here, ladder is about to slip. Okay. By chance in the question paper, they mention find the angle with vertical. You write let theta be the angle of inclination of the ladder with vertical. Or if somebody, but usually we want horizontal. See, if you take with horizontal, I told you this is cos, this is sine, you know it. But in case you take this theta, this will become sine, that will become cos. See, this cos will change over to sine. Nothing to worry, you can solve. Or some people may be there, no sir, we get confusion, no problem. If they ask what is the angle of inclination with vertical, you do one thing, you find the angle of inclination theta with horizontal only. Get the angle, how much? 56.310 degrees. Answer still you have to get it, is with horizontal, right? Therefore, with vertical it is 90 minus 56.310, angle is 33.69 degrees. I will not tell again and again now. Okay. Now, note, usual you should carry out. I will not explain. I will dictate. A is given, see, this is a rough surface here. See, they told one small sketch you write here. See, one small sketch you write here if you want. See, one small sketch here you write, show this way. This is actually here mu equal to what? They told mu equal to 0.25. 0.25. This is smooth. Therefore, right here, friction will come only at the base, ground level, no friction there. Why? Smooth wall. Therefore, usual statement, you take A, B, C, let RA be the normal reaction and frictional force at A when it is on the verge of slipping, FF limit at A equal to mu at A into RA will become 0.25 RA. This is told more than 1,000 times, actually not 1,000 times, plenty of times told. And here, only RB. Make a note here, friction is not there. Why? It is given smooth. Now, one more thing they told. See? The center of gravity of the ladder is at, one more thing. See, I don't think this L I will put later, okay, L. Okay. Right, one more. Let W be, see, in the question, weight is not given, W be weight of ladder. Okay. Now, right, in the, see, this is the ladder A to B. See, A to B, small letters. A to C, okay, A to C. This length is L. Don't see there. Separate sketch you write. This is L. No, not this one. Separate sketch here. Small sketch, L. They told center of gravity of the ladder is at a distance of 3 by 8 L. See, if this is L, if it is uniform ladder, center of gravity will be exactly at L by 2. You know it. Center of the ladder, along the length. Along the length center means, when you project here, this also center of this length. If you project there, that also center of that height. But in the question they told, center of gravity of the ladder is a distance of 3/8 L, means little less than half. Means your ladder may be like this, see? Maybe like this, little this way. Bottom little heavier or little more width, top lesser width. So therefore, center of gravity will be little downside. So any question given, okay, therefore, now right here, the centroid of the ladder G, that is where the weight is acting, see, weight of ladder acting, along the length it is 3/8 of L, see, 3/8 of L from here, make a note. Now, if this is L, if this is theta, L cos theta, L sin theta, systematically told in the first class of ladder friction. Then, this point, when you project here, see, this is 3 by 8 L, 3 by 8 of this L means this is 3 by 8 of this length. This also I told you. See, if this is 20% of this length. When you project here, this is 20% of this length. This all I told for you. So these things, or you can do one thing, if that much difficulty is there, see, you project here, make a point D, you consider this triangle, right? Cos theta equal to AD divided by A to this point, say AC or AE, or cos theta equal to AD divided by 3 by 8L. Therefore, this length will become 3 by 8L cos theta. First of all, studying engineering or already engineering finished, that much common sense required. See, if along the length from the base, if this is some percentage, k times of L, horizontally project it, it will see. I tell once again, I should not tell. See, if last time I am telling, see this way, if some point is here, if this is L, if this length is k times of L, if I project here, this length equal to, suppose this is a base B. If this is k times of L, this is k times of B. Okay, from here. Or, one more important, suppose, see, make a note. Suppose this is L. Some point here. This is k times L. If from top k times L means, when you project here, from here it will become, if this is base B, this will become k times of B. Or, easy to make a note, from a particular point, base, see, this way. As you go inclined way, how much percent of that inclined length, when you go horizontally, when you project it, that to reach that point, you have to go by same percentage of the base. Or, from the top, if a point is some percentage of length, see, when you project the top, projection will come that side. From there, same percentage you have to come. Okay. This much common sense required. Or these all I told you in the, see, class, not this one, the first class of ladder fiction. Class number I don't know. I told each and every, I told some advice come warning there. I have given a warning for you also. People who don't study properly and directly come to a class, don't understand, it is their problem. So these all you prepare. See, usual writing, mu, etc., these dimensions all you prepare. You carry out if you are serious. If you are not serious, don't ask me anything. Okay, start. Now, sigma fx equal to 0. See, as usual, xxyy here, sigma fx 0. See, 0.25 RA minus RB equal to 0. Equation number 1. Sigma fy 0 plus RA, nothing here. See, last time there was a friction here. So, it was mu times of RB. See, but this time it is not there. So, plus RA minus W equal to 0. Oh, this time RA will come plus W. Immediately substitute RA equal to plus W here. RA plus W. Your RB will come, see, minus 0.25 RA. Substituting RB equal to, see, take that side. 0.25 RA equal to 0.25 W. So now your RA equal W, RB equal to 0.25 W. Okay, now take moment about A. Minus RB into L sin theta. See, moment about this point. It's there. This also, engineering, mechanics, starting class, shouted. I should stop it. What if you take moment about a point? See here. Vertical load into horizontal distance. Horizontal load into vertical distance. I do not know how many times I told. People will laugh at me if somebody is observing everything I told, and if he is a good friend of me, he may tell me, why, what are you doing this one? How many times you are telling? They know, they are also equally good. I will tell you, don't know. They forget. I do not want anybody to get confused. So, therefore, I am telling it. So, minus RB into L sin theta plus W into, W is a vertical load, into this distance, 3 by 8 L cos theta equal to 0. Substitute RB equal to 0.25 W. So, minus 0.25 W L sin theta plus W into 3 by 8 L into cos theta equal to 0. See what will happen now, see here. when equal to 0, W will cancel, L also will cancel. You will get minus 0.25 sin theta. See, take that side, minus. Take that side. Or 3 by 8 cos theta equal to 0.25 sin theta, or sin theta by cos theta is 3 by 8 by 0.25. Is it correct? I'll check once again. Correct actually. 3 by 8 divided by 0.25 equal to shift tan inverse answer. Sorry. Shift tan inverse answer equal to, what is this one? Shift tan inverse answer. 56.3099 degrees or 56 point paradecimal 310 degrees. Okay. Now write a note here. Make a note. Therefore, under its own weight, no other extra force is acting. This ladder is on the verge of slipping. See, this ladder is on the verge of slipping. If this is a rough surface here and if it is a smooth surface here, when this angle reaches how much? 56.310 degrees. If the angle is more, see, if the angle is more, ladder is stable. But if you reduce the angle, it will easily slip. So, for stability, this angle should be either 56.310 or should be more, same way. Or if you refer this angle, it is 33.69 degrees. So, when this angle with vertical is 33.69 degrees, it is on the verge of slipping. By chance, if you increase the angle, ladder will slip. But if you decrease the angle, ladder will not be slip. So this is the minimum angle, that is a minimum angle, that is a maximum limit for the angle. For when the ladder is freely placed, no other weight, nothing, freely placed. See, people ascending the ladder, that all will come one by one now. Right now, I am doing free, only stability of the ladder. Okay. Now, question number 93 is a very interesting question. Okay. I will do one thing now. I will write the question first. It's a very interesting question. Yes, next question, 93, correct? 91, 93, okay. A ladder is of length 6 meter, numerical, see. 6 meter length ladder. Weighs 750 Newton. So weight is given 750 Newton. See, in the question they told weight of ladder is 750 Newton. Okay, right here. 750 Newton. That's around 75 kgs. If you go for gravitational MKS unit, okay. Center of gravity of ladder is at 2.8 meter along the length ladder, along the 2.8 meter along the length, along the ladder, okay, along the ladder from top, that is center of gravity is 2.8 meter along the length from the top. See, now last time I told from bottom, now from top 2.8. So if you want, you can do one thing, see, you can make a rough note here, see. If that is 2.8, this will be 3.2 meter. Anything will do. If you want, you can write. Okay. Now, the bottom of ladder is resting on, see, bottom of ladder is resting on a smooth horizontal surface. Very important. This is a smooth surface now, see. This is a smooth surface. Maybe some mosaic floor or some surface where fully oiled surface, anything, smooth given. So remember, smooth given means that is, remember, no friction possible. Actually, theoretically, okay, but practically, little friction will be there. They want to ignore it. Okay, then coefficient of friction for a ladder with vertical wall is 0.35 here. See, if that also is smooth, gone case. Okay, then find minimum angle of inclination of ladder for stability. So minimum angle they want means the angle should be either equal or more. Therefore understood. See, I told you minimum angle means what? The angle if more happy, stable, if less problem. See, This is unstable. So therefore, understood, it is angle theta, if you take, should be with horizontal. With horizontal. Understood. You write here, minimum angle will always come with horizontal. In the question, if they ask, find the maximum angle of inclination, understood, it is with vertical. Okay, therefore, right here, let, see, statement, solution, let theta be the angle of, right here, angle of inclination of ladder with horizontal, when the ladder is on the verge of slipping. On the verge of slipping. The statement you are right. Okay, then. First, usual. What? This is rough surface. So let normal reaction equal to RA. Friction is not there. See, there is no friction at A. And C, you write, let RC be the normal reaction, and ladder is slipping down means friction is up. It is mu into RC, 0.35 RC. So later, I will put RA here and here RC here and vertically up 0.35 RC. When I put the sketch, I will write that way. Then further, centroid is at 2.8 from top. So now, if this is 6 meter, this is 6 into cos theta. You know it. 6 into cos theta. This is 6 into sin theta. No place right here. Okay, right here. Okay. So this I remove now. Okay, already told. This is, you calculate and tell, this is 6 into sin theta. Now very important. See, the center of gravity from top, if you measure, it is 2.8 meter in 6 meter. So if you measure from here, see, when you project the point here, from here it is 2.8 by 6, that same ratio into what? To 2.8 by 6 into 6 cos theta. Sorry, 6 sin theta. Oh, not cos theta. Sin cos theta only. See, this is 2.8. This is 6 meter. Therefore, this length is 2.8. So if I project here, from here it will be 2.8 by 6 of 6 cos theta, or 6 and 6 will cancel, it will become 2.8 cos theta. This is 6 cos theta, this is 2.8 cos theta. Okay, 1 minute now. Or you can do one thing, see here. This is theta means this is theta. So cos theta equal to this side by this side. See, this side by 2.8 equal to cos theta. So this side equal to 2.8 into cos theta. That you can do. Last time, see, or you can do one thing. Suppose you don't like that 2.8, you can write from here how much? 3.2. See, 1 minute, first do it. Here, see. This is from here is 3.2. 3.2 in 6 meter. So this will be, ratio is what? 3.2 of 6. Same ratio into 6 cos theta. It will become 3.2 cos theta. Or see here, it will become same answer. These all I already told earlier. Therefore, no need of writing all these. Okay, now, some will wonder, sir, what is that sketch? Do not worry. I wrote a sketch for my practice. I have to take a class later where I have to go for support reactions for some class. So I am practicing that one. Imagine I am practicing that one. Don't see that side. And what is this, sir? FOANT? I will tell you later. What is that FOANT IKTINSQ? This is to safeguard my interest. Some people will comment. Okay. See. Okay, now start. Write free body of the ladder. See, sketch is given. We will put the ladder like this. See, this way we'll put the ladder. Okay, now see. This I will take A. This I will take B. This I will take C. Here, normal reaction RC, and this is C. See, this is C point. This is frictional force. Directly right here. Now already explained. Don't waste time. Point, how much it is? Point, where is it? friction coefficient 0.35. Okay, this is black. 0.35 is black color. 0.35 into RC. And here only normal reaction, because why? That is a rough surface. Here only normal reaction, RA. Then this length is 6 meter. Ladder weight is acting here. How much ladder weight? 750 Newton. Therefore, this distance is what? This is our theta. You have to calculate this theta. If that is theta, I already told you, this is 6 into sine theta. This is 6 into cos theta. Therefore, this distance will be, I already told you, 2.8 into cos theta. Okay, now, okay, leave it. That much you write first. Okay, now, start. Very important now. First, sigma fx equal to 0, right side positive. See, minus RC, then minus RC, vertical, friction is not there, vertical, that's all. No, minus RC, that's all. Okay, equal to 0. Therefore, your RC equal to 0. RC equal to 0 now. RC equal to 0. Okay, now, sigma Fy0. Take upward positive. Plus RA plus 0.35 RC minus 750 equal to 0. Now, RC is already 0. Therefore, you can tell what? Therefore, your RA equal to, see, when RC is 0, RA equal to plus 750 Newton. Oh, then, lastly, theta required. Take moment, this 6 cos theta, I will ship it here. 6 cos theta, space problem. Okay, lastly, sigma m about A equal to 0, take clockwise positive. Minus RC into 6 sin theta, RC is 0, no? RC is 0. Minus RC into how much? 6 sin theta, 1 minute. 6 sin theta, again minus, write everything, first of all write, minus 0.35 RC into what? 6 cos into 6 cos theta, 0.35 RC into 6 cos theta minus RC into 6 sin theta minus, correct answer, minus 0.35 RC into 6 cos theta plus 750 into, see, 6 cos theta, this is 2.8 cos theta, this will be 6 cos theta minus 2.8 cos theta equal to 0, correct? When this is 6 cos theta, see, moment about A, or you can put directly answer, this is 3.2 cos theta. Now, RC equal to 0. Therefore, what happens now? Therefore, all cancel here. When you equate to 0, 750 also cancelled, because why? See, okay, right here. Okay, therefore, 750 into 6 cos theta minus 2.8 cos theta is how much? 750 cos theta is 3.2 cos theta equal to 0. 750 cannot be 0. 3.0. Therefore, cos theta equal to 0. Therefore, your theta equal to 90 degrees. 90 degrees. That's the answer. Now, why it is happening that way? Remember, all this murmuring and acting as if, talking as if I am surprised when I got RC equal to 0, and then telling that what is this, how much coming, These are all is deliberate. I wrote first of all. First of all, note that I know this is nonsense question. First of all, I know that it's a nonsense question. This ladder can never be stable. The only way to stability is place the ladder exactly touching the wall vertically. See, you should, if you want stability for this ladder, your theta is 90 degrees. See here. If the surface here, wall here, you should place the ladder like this. The only chance is like this. Yes, that way you can place it here. That's the only chance. See, if you take it ladder, the moment it becomes inclined, ladder is unstable. So I told, first of all, note that I know that this is nonsense question. So that is not for my practice. Do you believe if I tell I have to take a class for some batch later where I have to solve reaction and I am practicing, nobody will believe in my class. If I tell, sir, what is that beam, sir, they will ask. No, that is for my practice. That class is there, no, for me. Sir, you are joking. Why? They will wonder, you are practicing, sir, something unimaginable. Okay, there's a purpose for writing. See, there is a purpose for writing this one. I want to explain something for you. Or this question, first of all, this ladder, theta is 90 degrees. Means what? This ladder cannot be used as a ladder. You make a note here. Therefore, the only way the stability of ladder is possible is when the ladder is not inclined, it is placed vertically flush with the wall. See, then also it may be slow, see, correctly placed with the wall. This way, somehow do it. By shaking, it will be in equilibrium. But a little slant means it will slip. So first of all, this question, when I gave the question only, I know the answer. Or make a note here. So therefore, see, make a note here. In the absence of, see, very important, in absence of any external force, that is when only what? Weight of ladder considered, or considering only ladder, people going up and down later, only ladder, then see, if you place this way, see here, you make a note here. If this is rough and this is rough, okay, no problem. We solve the question, first question, right? Okay, no problem, you write here. Nothing to worry. It is stable, stability is possible, some theta will come. Ladder can be placed at a particular angle so that it will not slip. Okay. Or, next make a note. Or, suppose this is rough, see, ground is rough and wall is smooth, then also okay, see, then also okay, answer is there, because see here, what will happen is, then write a note here. If I take A, B, C here, same, I will take A, B, C, A, B, C, then there is only normal reaction here, RC. Here, normal reaction RA, and slipping this way, friction will come this way. What? Mu into RA. Whatever mu here into RA. Now, see, this RC is balanced by mu RA, and whatever weight W is there, it is balanced by this RA. See, weight of ladder is balanced by the base reaction. You see, this will balance this one. So whatever weight comes, the entire weight is transferred to ground because there is no friction there. And whatever friction comes here, it is balanced by RC. This also okay. This is your last question. But right here, But this all, see those who are, see, otherwise you write angle theta 90 degrees and stop the question. Stop the question, that's all. But, see, but I told in the absence of any external force, only when you place a ladder by chance, see here, if this is smooth, whereas this is rough, the moment you place the ladder at any angle other than 90, the moment the ladder is inclined, it will simply slip. There is no chance of survival because, see, there is a normal reaction here, RC. There is a normal reaction here, RA. There is a friction here coming this way. What? Mu into RC. Whatever mu here into RC. And weight is here, W. Now see, weight can be balanced, but this RC, there is nothing to balance it. See, the RC will come when friction comes here. When there is no friction, RC will be 0. See, just now you got. Therefore, this ladder cannot be stable, or common sense. See, suppose there is a wall there and floor here, only ladder. If both are rough, you can have little more inclination, no problem. See, you can have lesser, with horizontal, you can have lesser inclination. You can have lesser inclination also. Stability is there. If there's a wall there and a floor here, you can place the ladder, you can have an inclined ladder, no problem. And if the wall is smooth, first case I told both are rough, good, very good. If both are rough, very good, stability is more. But if the wall is smooth, but the ground is rough, yes, you can somehow, it will lean there, the friction here will prevent it from slipping. But whatever is the roughness there, whatever rough you make it there, if the base is smooth, ladder will not stand. The moment you place, see, like that, it will slip. That's why only possible way to place the ladder is make it lean on the wall. See, take the ladder vertically and put it here. That's the only chance. Now I will tell you what is the, why I wrote this one. See, therefore, because if it is this way, with the inclination, equilibrium does not exist. See right here, with inclination, equilibrium does not exist. Okay, now see here. Just for understanding the concept, do one thing. You take an example. A beam, 1 minute here, see. I will take a horizontal load here. Horizontal load of 8 kilonewton. You take a beam AB of span 5 meter, distance 2 meter from here, vertical load of 20 kN, horizontally 8 kN. One more beam you take. This is your, see, first, you take one beam, first beam. Same way, you take a beam here, see, one end hinged, other end placed on horizontal roller, this way, AB, of span 5 meter. 5 meter. A load of how much? 20 kilonewton here at 2 meter from here, and a distance of, this is, if it is 2 meter, this will be 2 meter sufficient. Okay, then also a horizontal load of 8 kilonewton here at a point C in between. Okay, now we want to find, this is one beam, right side hinged, left side placed on horizontal roller. Second beam you consider right side hinge, left side placed on a roller in the vertical plane. Remember, not the restrained roller. That is a clamped roller. See, it is not this way. See, one more is there later in structural engineering. This is something else. They tell guided support or some name. Restrained roller. This you get later, not this way. Simple roller. See, rolling in the vertical plane. Okay, now you want to find reaction. Okay, start. Here, see what happens now. This is A, this is B, start. Both the questions, see, B is for, see, I am telling common statement for both the question. how to find support reactions. You are using equilibrium conditions. Okay, start. B, both the cases, B is hinged support. So it can resist what? Offer vertical reaction and horizontal reaction. So let what? VB be the vertical reaction here and HB be horizontal reaction. Here also, see, let VB be vertical reaction, HB horizontal reaction. Then write. For a you should write it, I'm explaining. For a roller support, simple sliding support, see, simple sliding support. I told earlier, long back I told, this way roller, it cannot take horizontal reaction, it can take only vertical reaction. Or a simple type of sliding roller, only possible reaction is reaction perpendicular to the plane of the roller. This all told earlier in the reaction chapter, long back. So therefore, this is reaction at A perpendicular. Since it is vertical, it is VA. And here, the reaction is perpendicular. See, this is reaction at A is HA. Why? This roller is horizontal, reaction vertical. This roller is vertical plane, reaction horizontal. Okay, now, right here, both the cases, number of unknowns are 3. Number of unknowns, see, 1, 2, 3. Put the load once again. How much load here? 20 kilonewton and 8 kilonewton here. Okay, this is 2 meter. This is 5 meter. Okay. Okay. Right here. Both right here. After you write both the sketches. Write some statement. Both the beams. Each of the beam, number of unknowns are 3. See here. VA, VB, HB. 3 unknowns. 3 unknowns. There are also 3 unknowns. HA, HB and VB. So, and we have 3 equilibrium conditions. Namely, sigma. See, when you go to beam, I don't use sigma fx, sigma fy. I told you I am using sigma h0, sigma v0. I am changing over now. Sigma what? H equal to 0, sigma v equal to 0, sigma m equal to 0. These are the equilibrium. Or sigma v0, engineering mechanics, you call sigma fx equal to 0. Sigma v0 you call usually sigma fy equal to 0. This you call sigma m equal to 0. I told engineering mechanics I am calling xy. In strength of materials onwards or support reaction, see earlier also I used sigma h and sigma v. Because why? I want to prepare you for structural analysis. We have done so many support reaction questions. See there, I don't know how many questions are solved. Endless, more than 100 questions are solved, support reaction. Okay, write all these. Therefore, write a note here. Somebody will tell both are statically determinate and we can find the support reaction using basic conditions of static equilibrium. Suppose you do not know what is statically determinate or indeterminate, wait for some time. Let us go further later for strength of materials. When I start SFD BMD, I will give brief introduction regarding determinate, indeterminate and very thorough explanation regarding stability and degree of indeterminacy. There are 2. One is called static, other is called kinematic. That all I will tell when you go to structural analysis and start analysis of statically indeterminate structures. Long time is there. Till that time you believe what I tell. So anybody will tell, yes, I can solve both. I will tell, okay, solve. Come on, solve. First I will solve this question. Okay. I will solve this question now. Okay. Someone will tell you, see now what he will do. Sir, I will solve now. Okay, solve. Sir, sigma m about A0, sir. Okay. Usually see, I told you, even though equilibrium you write sigma h0, sigma v0 and sigma h0, when you apply actually in structural engineering, in strength of materials later and structural analysis, we apply in the reverse order. Reverse order. Because advantage is there. I will tell you advantage is there. So usually from the moment I leave this friction chapter, enter strength of materials and later structural analysis, so many questions. See there, more than 500 questions I will solve. There, our order of application will be first sigma m0, then sigma v0, then sigma h0. Okay, start. Sigma m about a equal to 0. Minus vb into 5, okay, unknown first. Minus vb into 5, okay. Plus 20 into 2 equal to 0. Therefore, vb equal to 20 into 2 is 40, divided by 5 that side will come plus 8 kilonewton. Plus 8 kilonewton. Okay. What is the meaning of this plus? All I told earlier, when I go to strength of materials, I will explain once again, or for that matter, when I am in the YouTube, I am uploading one more, in the special class series, I will upload a class where sign convention problem. So therefore, right now leave it. Sigma v equal to 0. Take upward positive. You get what? This question. Plus VA, see here, plus VA, plus VB, sigma V0, minus 20 equal to 0. VA, already you know 8 kilonewton plus, substitute, your VB will come plus 12 kilonewton. And sigma H equal to 0, take right side positive, HB plus HB plus HB. One thing forgotten. When you take moment about A, remember it is HB into 0. Why? Line of action of HB passes through A. Remember, make a note here. HB into 0 at that time. That's why not considered. Okay. HB minus 8 equal to 0. You will get HB equal to how much? 8 kilonewton. Therefore, instead of wasting time, you write here this VB equal to how much? Enter here. You write one more sketch. VB equal to 8 kilonewton upward. You have taken positive, correct? Your VA equal to how much it is? VB equal to 8. VA equal to 12 kilonewton and HEB equal to 8 kilonewton. Okay. This is the result for this question. Happily solved. Okay. Now solve here. Sigma m about A equal to 0. Clockwise positive. Okay. Here. Minus VB into 5. See. Minus VB into 5. 5 is black color. Okay. VB into 5 plus 20 into 2 equal to 0. HB into 0, not there. Therefore, your VB will come 20 to 40 plus 8 kilonewton. Okay. Then sigma V equal to 0, upward positive. Plus VB minus 20 equal to 0. What is this one? Again, deliberately I am telling. I only set the question. This will give VB equal to plus 20 kilonewton. Right? What is this nonsense? What is this nonsense? Nonsense. Therefore, stop and discuss. Discuss. See, here, vertical reaction, when you apply load here, it will press both the support. We got vertical reaction. Horizontal reaction balanced by only this support. Okay, but here what happened is, when you apply a vertical load here, this cannot take vertical reaction. Only this load will take vertical reaction. Then, when you take moment about A, see, what you get? Minus VB into 5, okay, okay. See, when you do sigma V0, what you got? VB into 5, or you can do one more thing. When you make sigma V0, you got what? VB minus 20 equal to 0. Substitute VB equal to 8 kilonewton. Substitute VB equal to 8 kilonewton. What you get? 8 minus 20 equal to 0. 8 minus 20 equal to 0, or minus 12 equal to 0. What is this nonsense? This is actually more I will not talk now because it will be told in detail when I go to structural analysis, where one class, maybe 3-4 hours class will be there regarding stability of the structure. Yes, remember, sometimes number of unknowns can be equal to number of equations. People will be tempted to tell determinate. It may be determinate from equation point of view. Structure can be unstable. So the structure is unstable. Unstable because you see here, if I put my hand here, see here, if I put my hand here, see here, 20 will create clockwise moment, 8 will create anti-clockwise moment. See, 20 into 2 is 40, 8 into 5 is 40. This clockwise moment is balanced by anti-clockwise moment. Or if I put my finger here, 12 into 5 is how much? 12 into 5 is 60 clockwise moment, 20 into 3 anti-clockwise moment, 60-60 balances. But if I put my finger here, if VB is 8 kilonewton, 8 into 5 anti-clockwise, 8 into 5 is 40, and 20 into 2 clockwise, it looks like balanced, but sigma m should be 0 about any point. But if I took my finger here, then 8 into 3 will create anti-clockwise moment. There is nothing to balance it. Therefore, this will rotate. See, when a sliding roller, when a roller is this way, when you apply load, it will come down. So if I take moment about B, 20 into 3 anti-clockwise, that is 60 kN meter, there is no balancing moment. Therefore, the structure is unstable. Or remember, you can decide whether structure is stable or unstable by observation. Or when you suppose it is unstable, suppose you cannot make out, nothing to worry. When you solve, you will get a nonsense answer. You will get a nonsense answer. Or the moment you get nonsense answer, you got what? Once we got VB 8 kilonewton, then you got VB equal 20 kilonewton. How possible? One unknown has got only one answer. So these two different answer. Or if you substitute that VB 8 here, you will get what? 8 minus 20 equal to 0, minus 12 equal to 0. Therefore, if the structure is unstable, if you apply equilibrium equation, you will get nonsense result. Whenever you get some nonsense result, remember, we are not talking nonsense. That is, structure is unstable. Furthermore, I will discuss later. So our question, our ladder friction happened. That's why I told. So if the wall is rough and floor is rough, no problem. If the wall is smooth, floor is rough, no problem. See, suppose you got a ladder. You want to put the ladder and go along the ladder. You have a very rough wall, a rough ground. I think you will put the ladder and go. Suppose you see that wall is fully painted, very smooth, but the ground is very rough. You will have confidence. Okay, somehow you can manage. But if you look at the ground, if it is fully oil, see, full oil is there. The moment you put the ladder, it will slip. It won't stand. The only way to make it stand is place it vertical. Then why you want ladder? Can you climb this way? You are not a Superman or Spider-Man. You are human beings. You can go this way. This way we can't go up. Only Spider-Man can go up. We can't go up that way. Okay, therefore, make this note. So today's class, we solved 2 questions, but we learned lot of things. Anyway, these all will coming later. Don't worry. I just told because time has come. So if you are interested, go through. Or you write there only theta 90 degrees and stop the question. Okay. Thank you. Next class we'll meet.